In this video, I'm going to cover complex numbers. I'm going to assume that you know the basics of complex numbers. Hence, this is how to use Maple to generate and work with complex numbers. Let's get started. Maple defaults by using the capital letter I to represent the square root of -1. Personally, I don't find this as readable, but you can use the other symbols in the common symbols to represent the square root of -1. For example, I've made z1 equals 3 plus 4i. I can make z2 is equal to 3 plus 4 times, and then I go down to the capital, and I have an I have an I that is not italicized, and it produces exactly the same thing. For people who use J, same situation, you can use 4 times and use this letter J, and when you hit enter, they all represent exactly the same variable. Personally, I prefer to reset the interface value for square root of -1 by using the interface command. So I say restart, and then I say interface, open parentheses, that the imaginary unit is equal to, and I can either say I or quote I, and it will do that. So now it is defined as I. So if I say z1 colon equals 3 plus 4 times I, it will rewrite it as the little I, but again, not in the italicized format. I've created 2 complex numbers here using, again, this change of the interface for the imaginary unit. But once you have them, it's pretty easy to treat them just like vectors and be able to add them or subtract them, or even to multiply them by constants. If you need to take the complex conjugate, the easiest way is to write it out. For example, z1 complex is equal to the conjugate of z1, and instead of being 32 plus 28, it's 32 minus 28i. Fortunately, even again, Maple allows you to write it as you would probably expect to see it, which is z1, and then hat 6, or the character over the 6, times a star, and then it turns it that way. Once you have the complex conjugate, of course, this allows you to calculate the modular value of it. So if I z1 times z1 complex conjugate, and not surprising, we get a real result. You can also do it just by using the absolute value sign. So I say absolute value of z1 squared, it will also calculate the modulus squared of this complex number. Notice that if you have z1 in this representation, you can represent it in a polar coordinate representation. That means knowing the magnitude and the angle of the real axis on the complex plane. So for example, in here I have defined z1 again, and I've been able to calculate the magnitude of z1 and also this angle, which is the arctangent of the imaginary component over the real component. Once I have this expression, I can create the z1 polar, which is defined as the z1 magnitude times e to the I times phi 1. When I calculate the value, I get exactly back the representation of z1. In addition, Maple will be able to solve any function that happens to be complex and return a value in a complex format. For example, here we have a function of q. So if I say f of 1/2, and I put the value in, it returns a complex number. Let's try another one. F of 1.5, it now returns it as a complex number, but now as a floating point complex number. Go. In addition, if you want to plot the real part and the imaginary part of this function, it's pretty straightforward because, again, using RE or the fancy icon of R and the fancy icon of I, you can plot out the real part and the imaginary part on in a 2D plot. The same also will apply for a 3D system as well. There are more complex plotting options available in Maple, but this gives you the basics. Okay, let's say we have a function that is a function of a complex number. And what we'd really like to do is to express it in terms of a function of a real part plus a function of the imaginary part. Well, basically what we're saying is we would like z to be represented by a expression a plus bi or a plus ib. Now, if we do this, the problem is Maple doesn't know anything about a and b and could assume that those two variables are also complex. So what we can do is we can simplify this by asking for the real part of our f expression plus I times the imaginary part of our f expression, all assuming that everything is real. And when it does, it produces the output as you see here. Since this is a bit cumbersome, Maple has come up with another expression will do exactly the same thing, and that is the evalc. When you ask for the evalc, it assumes all variables inside the expression are real. Evalc, evaluate complex, our f expression. Given that a and b are real, you can plot out the real part of f using a plot 3D. Again, there are more complex ways of doing it in Maple, but this is the simplest way in terms of visualizing the function f of z. Questions? Leave them down in the comments. I'll try to get to them. I'll try to make also another video on how to use some of the more complicated and sophisticated ways to making complex plots.